Better Buildings for Humans is powered by Advanced Glazings, makers of the Solera line of products. Solera is the leading glass glazing made specifically for architectural daylighting and with extreme insulation performance. Learn more at advancedglazings.com. Hello and welcome to this week's episode of Better Buildings for Humans. I'm your host, Joe Menchefski, and this is the podcast where we take a look at the impact that the built environment has on our health, our wellness, our productivity, and our general joy of being alive. And of course, we always have to talk about sustainability as well. And on that note, I'd like to introduce Dr. Felix Heisel. Dr. Heisel, welcome to the show.
Thank you for inviting me.
Now, it's an absolute pleasure to have you here. Felix, let's start by letting our listeners learn a little bit about you. Tell us about your background. Tell us why you chose architecture, and then talk about the road that led you to have this special interest in the world of circular building or circular architecture.
Happy to. As you mentioned, I'm an architect by training. I did a very traditional architecture education in Germany at the University of the Arts. And I was always sort of driven to the spatial potentials of architecture to lead better lives for everyone involved, either living in these buildings or living around these buildings, right? Both the indoor and the outdoor opportunities of architecture. But then the shift to what I'm doing nowadays is influenced by sort of the last 15 years of learning about the influences of our industry on the planet. The negative side, if you look at the impact of buildings across their whole lifetime, from the production all the way to the end of use, buildings are responsible for about 50% of materials that we take out of the Earth's crust, 40% of solid waste that is being generated, and about 40 of, I think the recent statistics say 41% of carbon dioxide emissions. These are global numbers, but they show how detrimental some of these effects are of what we are doing as an industry. And personally, I had the chance to live on several different continents right after finishing my studies. I moved to Africa, and then from Africa, I moved to Asia, and was teaching and researching there and kind of seeing these impacts firsthand in different contexts. And so that essentially led to a book project in 2014, which was called Building from Waste, and kind of set off this journey ever since then.
Oh, there's a couple of really interesting things in there that I have to come back on. I mean, first of all, the 50% of the materials that come from the earth go into buildings. I'd never heard the number. I'd certainly heard the 40% of carbon dioxide, but 50% of materials are used in creating buildings. That is absolutely huge, absolutely huge. And can you tell me the name and the title and the author of that book again that you just mentioned, just to make sure that people hear that?
Yeah, so this is a book that I co-authored with Dirk Hebel and Marta Wiśniewska. It's called Building from Waste, and was one of the first books that sort of tried to shift our perception of waste from a byproduct or a problem to a potential resource for future products, specifically focusing on the potentials of waste for the built environment.
Oh, perfect. Yeah, forgive me. I didn't realize that you're a co-author. That's fantastic. All right. I didn't mention at the beginning, Felix is at Cornell, and he heads up what's called the Circular Construction Lab. And we're going to start there. Actually, very much of this episode is going to be built around the Circular Construction Lab because I love this idea. It's very exciting. First of all, tell us why the lab was created, the objectives, and tell us about the methods that you're using to achieve those objectives.
Yeah, so when I was appointed at Cornell University, I started the Circular Construction Lab as sort of my research hub, platform, vehicle. And it's really set at the intersection of several different disciplines because our assumption is that the questions that we're asking are so large that they are systemic questions, and they need to be answered by sort of a collaboration of disciplines rather than siloed questions within sort of unique departments. And so we're drawing students of naturally architecture, but also urban planning, civil engineering. We had a couple of mycologists, biologists recently. We have computer scientists and system engineering students. And so that group tries to answer basically two large questions. And they are granted very large questions. One being, what can we do with all the materials that have been sort of brought into the built environment up to today? So all the materials that you see around you, the walls, the ceilings, the floors in all the buildings, how can we understand those as a resource for future construction? And what would it take to actually bring those materials back into an economy, meaning technologies of extraction or harvesting, the business models that are involved in this, policy and code that is required to allow for their reuse. So that's a large scope that we're setting ourselves on that question. And then the second one is, and this is more kind of our teaching focus, is the question, how would we need to design buildings differently from now on so that the buildings that we design today don't run into the same problems at their end of life that we are just talked about and researched with all the existing buildings, right? And the key focus there is our built environment today is not built for reuse. Usually the disassembly or the end of life of a building is not a design parameter. When we start out, right? When the client comes to an architect, the first question is, how do we take this building apart again at the end of the use? But the first question is, how do we design a beautiful building, right? But the task really is to think about the whole life cycle when we design and build, and that would create different cities, different ideas of how we manage our cities. And that's a really exciting field of investigation.
Short lifespan, single-use plastic glazing is not a sustainable solution for daylighting. Solera is the glass-based alternative for the new millennium. Learn more at advancedglazings.com. Yeah, you said the term the end of life or the use of materials at the end of life is not a design parameter now. That is a really brilliant insight. And we're going to dive deeper on some of the things you just talked about. Let's go right now. Start with a couple of sort of definitions. I've had several guests on the show to talk about regenerative design. How is circular construction different from regenerative design?
They are sort of two versions of or subfields of a larger idea. If you look at the definition of a circular economy, this coming from the Ellen MacArthur Foundation, which is sort of leading the drive on circular economy thinking, then that definition starts out that the circular economy is a system by design that keeps materials at their highest utility and value at all times, right? But also it is a system by design that regenerates nature. And so you have these two components actually already in that definition, right? The circular construction is much more focusing on questions of design for disassembly, the reactivation of materials, and questions of connection details, sort of the technicalities of it. Material selection is part of it because, of course, we don't want to build with materials that create a problem down the road. But regenerative design is more focusing on, for example, the selection of biologically harvested or biologically grown materials, the reduction of the embodied carbon footprint through material selection. And so while they both try to move towards a different way of construction, right? Circular construction, from my perspective, really deals with the how we build, and regenerative design a little bit more with what do we use to build, right? Maybe another aspect that is interesting is that circular construction has this focus on the past as much as on the future, because it's really also tackling, so what do we do with everything that's already there, right? How can we reactivate all of these resources for future buildings? And that part is a little bit less a focus of regenerative design, at least from my perspective.
Okay, you mentioned the term design for disassembly several times. We have to learn a little bit more about that. Can you define it and maybe give us an example or two, Felix?
Yeah, I mean, maybe we can define it first by showing the problem. I mentioned earlier that the current built environment is not designed for disassembly, meaning that we, for example, use a lot of adhesives in the way we construct nowadays. We use foams, we use silicons. All of these are chemical connections that bind different types of materials together, in many cases in ways that are not reversible. And the problem with that is that these composite materials, as a result, are often non-recyclable or non-reusable. And so the way we build, per definition, creates waste at the end of use of, or the end of life of that building. And design for disassembly is sort of the opposite. It starts in the design process to consider that end of use or end of life scenario and makes decisions upfront that prevent waste from happening in the future. In many cases, this has to do with connection details. So how do we connect these materials in ways that are reversible, that are able to be taken apart in sort of their pure material characteristics so that they can then be reused and recycled at their highest utility and value as the circular economy definition requires. But it also has to do with the economics of this, right? So what is a good product that then makes sense to reuse? And so it's not just about the connection detail, right? It is about sort of designing a system that makes sense over several use cycles.
Okay, I see two different scenarios, and I'm going to ask you to help me. Are they both designed for disassembly, or is it just one? So in one scenario, let's say you can take all the wood, you can chip it up, you can use it to make chipboard or some other new products with the fiber from the wood, or you take the concrete, you mash it all up, you take the steel, you melt it down and use it again. That's one scenario, right? The other scenario is Legos. Right? The little boy builds a castle with the Legos and then takes apart all the Legos, and the next day he builds a car with the Legos. I'm imagining, panels or things that I can literally take the building apart and make a different building over here now. Are those two scenarios both designed for disassembly?
So what we're aiming for is the second scenario. Where when we talk about design for disassembly, we're talking about a city or a building that is thought much more about like a warehousing of components or a asset management, about sort of a warehousing or asset management of components, and components that ideally remain in their physical configurations when they then move towards reuse. The first scenario that you talked about is much more a recycling scenario. The moment you talk about melting steel or chopping up wood, you're bringing energy into the equation, right? You're adding new energy to make something different out of it. That is unfortunately the status quo of our industry, but it is much less sustainable and much less circular than reuse. And we can talk about the differences for another hour. But I think that the key differences are that if you look at sort of the circularity, the hierarchy of strategies that we talk about in the circular economy, right? From first of all, the prevention of waste, but then reuse, remanufacture, recycling. The most sustainable is direct local reuse, right? And that has to do with, of course, the prevention of transportation emissions, for example. It has to do with or let's put it this way, the economics and the ecologics of that are sort of obvious. There's a much more impactful reason why local reuse is more important from our perspective, and that is the fact that it creates local jobs. It keeps materials in the community. It is a kind of job training opportunity, workforce development, and it keeps historic and cultural identity alive in a community. And these benefits, I think, are in the end as important as the fact that we're reducing transportation emissions and saving the environment, right? It's about how we live together on this planet. And so local reuse can do that for you, while recycling, which is per definition out of economic reasons, out of the economy of scale that you need to make recycling profitable, right, is a global endeavor. And so the steel that we're recycling sometimes ends up in Asia or in Africa. The emissions that are associated with transporting that steel across the ocean probably offsets all the benefits that we have from not going for virgin resources. So there's many questions that we can have about recycling, and they can all be overcome by the alternatives of much more local.
Right. Okay, I'm going to use a paper that you were part of in order to really do a deeper dive on this and maybe understand circular construction a little better. So your lab, the Circular Construction Lab, released a white paper last year. It was specific to New York. It was called Constructing a Circular Economy in New York State, Deconstruction and Building Material Reuse. First of all, let's talk about the creation of the paper. Can you tell us about CROWD? And that's an acronym, CROWD, and the network of collaborators on this paper.
Yeah, as I mentioned earlier, you can't do any of this alone. This is a collaborative effort that needs all the different disciplines to work together. And so in 2020, we founded CROWD. As you mentioned, it's an acronym that stands for Circularity, Reuse, and Zero Waste Development, short CROWD. And this is a group that started in Ithaca, driven by local demolition of historically relevant buildings and the community outcry that came with it, but very quickly grew into a New York statewide policy advocacy group working towards material reuse and deconstruction. And as a group, we've, over the last years, published several reports, cited policy templates, and have been very active in just communicating the need for a change. And the white paper that you mentioned is the recent large publication that CROWD published. And it's sort of started from conversations with New York State Assembly members and senators on the need for policy recommendations and a much more broad understanding of the benefits of a circular economy for the state, both in terms of the environmental benefits, but maybe more important in this case, the economic benefits. So the paper can be used to convince other members of the Assembly and the House to vote and support these potential bills that are being drafted right now.
Right. Okay. All right. Let's dive in a little bit. First question I had, the paper talks about the disproportional impacts of a linear life cycle on disadvantaged communities. Can you explain to us how communities are more adversely affected, how these communities are more adversely affected by our current linear way of building buildings?
Well, a lot of this has to do with the end of use of our current system, right? We're creating immense amounts of waste that are associated with construction, be it buildings or infrastructure. And the question is, what happens to that waste? And if you look at a map and you locate our transfer stations and our landfills across the nation, but we did it specifically for New York, then you find out that the majority of these locations are actually situated in the vicinity or inside of communities that are considered as disadvantaged communities at the moment. And then you add to that, there's a huge amount of transportation associated with these locations, right? You have trucks going in and out of these landfills. You have emissions from these transportations. You have large emissions coming out of landfills. Not just in terms of carbon, but actually much more important, the methane that comes out of landfills. You have water pollution, air pollution that is associated with these sites. And so the location matters, right? And it unfortunately hits those that can defend themselves more often.
Right. Okay. All right. I gotcha. Let's switch to economics a little bit. You talked about economics a little bit earlier. Is circular construction a smarter move in terms of the economics? And I'm just talking money. Let's just make it dollars and cents for just a moment. Do we save money by moving from linear to a circular construction economy?
There are like 1,000 answers to this. This is not an easy question.
Sure.
But we can try to unpack this question maybe in several tiers. The first and obvious answer is deconstruction. And I don't think we've defined deconstruction yet. So what we understand with deconstruction is sort of a systematic unbuilding of a structure that has as its main goal the reuse or the reusability of the materials that can be salvaged in that process. And so it's, in our definition, the sustainable alternative to demolition. It is not an alternative to any other higher strategies in the waste hierarchy. So if you're able to reuse a building on site, please reuse it. If you're able to adaptively reuse it. If you're preserving it for historic relevance, please preserve it. But if it comes to the point where that building needs to be cleared and the site needs to be emptied for whatever reason, what we understand as deconstruction is sort of the last resort that then allows for all the materials that are currently contained in that building to find a second use. And demolition does not allow for the maxim of demolition is clear the site as quickly as possible. And unfortunately, in New York State and many other states in the US right now, that usually means to landfilling of materials, usually in mixed form, so that even the recycling potentials shrinks even more. Now, if you ask me if demolition or deconstruction which one is cheaper, the answer, unfortunately, right now is always demolition. But
Right.
that has to do with the fact that that society is paying the difference, right? In the demolition, like if you ask for a bid for a demolition, you have tipping fees included, right? But you do not have the operation of the landfill included. You do not have the air pollution or water pollution that comes out of that landfill included in that bill. Society covers that difference, right? And that's covered by your taxes, that's covered by, the communities that are around you, but it's not included in that number that you're going to get from your demolition contractor. In the case of deconstruction, you're paying more workers for a longer time to do a careful job with the goal to prevent waste and with the goal to keep materials in circulation and bring them back into another building, right? So the first question, if you ask it, you said we're only talking about dollars, but I don't think that's the right question to ask.
Fair enough.
There are much other benefits of deconstruction that come with it, right? I talked earlier about the fact that it, for example, creates jobs. The fact that you're paying more also means that you're paying local labor you're paying salaries, you're bringing something good to the community, right? And the point is, if you look at it at a longer timeline, in the end, you might actually be cost competitive because the materials that you're salvaging, of course, have an economic value. And so the resale of these materials in the examples that we've done so far cover the difference between demolition and deconstruction. So yes, the initial moment when you're taking that building down, you pay more. But then over the next couple of months, you're going to start selling these materials, you're processing them, you're selling them, and that tends to offset the difference. And so in the end, demolition and deconstruction are actually cost competitive. We've also proven that they're time competitive. We've taken buildings down in 5 days. Demolition is maybe 2 days. So if you ask time is money, I think we're also in that realm. And so what the white paper now, sorry for the long answer, but what the white paper now tries to do is to kind of understand what is the economic potential of that shift at a state level. And so we did economic impact calculations, assuming that we could either move 50 or 75% of all demolitions, current residential demolitions in the state, from demolition to deconstruction and try to understand what would the impact be of such a shift. And the numbers that came out of that is that we're assuming there's a 3.05 billion US dollar impact for the state of that shift, that there are about 13,000 new jobs that could be created in that move, and that there are large amounts of waste that can be prevented from that move. And so what we're trying to show is that, yes, there is an economic benefit and an economic potential of doing a large shift towards deconstruction and material reuse.
Well, on the micro view, though, Felix, if you truly were designing for disassembly right from the beginning, not dealing with what we have now, but if you're designing for disassembly right from the beginning, the economics have got to be very strong relative to demolition, wouldn't they?
Yeah, I think that those are two conversations that should be, as you just pointed out, should be separated. All the conversation that we do when we talk about deconstruction, that always deals with something that wasn't meant to be disassembled, right? Otherwise, we wouldn't have to deconstruct it. If the moment we shift and say, well, we can just take this thing apart and reshuffle it and put it back together, that is economically a very interesting idea, because most buildings right now, we actually, when we look at the cost of construction, I mean, similar to maybe the cost of demolition, we tend to right now only think about the moment that someone moves in or the moment we develop that building and then we sell it off, and that's sort of where the calculation stops. If you look at the whole life cycle of a building, many of our buildings right now are essentially a liability at their end of use, right? You need to, like, you have something, you own it, right? It has a value, but at the end you have to pay for its removal, which is sort of a paradox, because you tend to say it's worth something, right? You're living in a house that is worth something, but you have to pay for its removal at the end, right? And so if we design for disassembly, then you're actually retaining that value of the materials, right? And are able to sell those off. So there's money to be made at the end of a building's use and not a cost associated with it.
Manage the connection between building occupants and the outside world using Solera translucent glass. Learn more at advancedglazings.com. Right, yeah. Okay, that's great. Let's talk about supporting, the systems that need to be in place to support this sort of new economic approaches, new approach to construction. How much does the existing value chain or the existing infrastructure need to change in order to accommodate a circular construction economy?
Yeah. In the paper, we make 19 policy recommendations that would need to change. And those are not sort of sequential. Those are ideally all happen in parallel, although that's a big ask. But we categorize them in 5 groups and that sort of address different moments in the life cycle that you just mentioned. So we have questions about how do you build the workforce that does this? How do you build the market for the materials so that you can actually sell them once you salvage them? How do you build the infrastructure that is necessary to actually do the deconstruction? How do you create long-term circularity and sustain this model over time, right? And then the 5th one, because it is so New York specific, we were asking what can the state do in terms of their own build and their own buildings, for example, their own infrastructure to lead by example. And there's quite a bit our states could do because of the fact that they tend to be the largest holder of real estate in the state. Is usually the state itself. In New York, it's the university system of the state that has about 40% of buildings, the state-owned buildings. And so if just the university system were to say, let's implement circular economy paradigms in our own building stock, that would be a huge market to develop and drive these systems, which could then trickle down into other economic players. But you're right. So there are strategies and shifts that need to happen along the whole life cycle or value chain. And some of those are budget asks, right? So it would help if we incentivize certain elements along the line until we reach an economy of scale, for example. We're not asking for kind of a continued support. This is really how do we make that shift until it sustains itself, right? But other asks are not budget asks. They're more, how could we gather data better so that we can actually use this data to design these systems? The state right now, for example, is rather bad at collecting its waste data. We're still using handwritten reports from each first station that is saved as a PDF, not centralized. So there are simple in quotation marks, updates to the infrastructure that would tremendously help to understand the value, understand the market, understand the material makeup, and how we can reuse these materials better. And so, yes, there's something to do, but the good news is, right, that you can do all of these things in parallel with different stakeholders along the way to build that system.
Okay. You literally just answered my next two questions in that response. So that was really good. If you had to sequence anything, you'll need manufacturers of the Lego blocks. You'll need storage facilities for the Lego blocks and distribution for the Lego blocks. You'll need post-use, like after the first use while they're awaiting their second use. You'll need storage and distribution for the Lego blocks. You'll need skilled laborers who know how to assemble the Lego blocks. Where would you start? What would you say are, the first steps?
The interesting thing is this has been done before. There are, I think, 10 cities in the US that have a deconstruction ordinance.
Okay.
In most cases, these were sort of unanimously approved by the community after long processes of policy development through, for example, advisory committees. The first one that was passed is Portland, Oregon, which is not necessarily surprising considering the incredible value of the timber that you have in old houses in Portland. This kind of old growth lumber, nominal material. But over the years, we now also seen, for example, San Antonio pass a deconstruction ordinance, and that's the 7th largest city in the nation, right? So we're talking scale here, which is really great to see. And what we've learned from these is that, of course, the moment you mandate deconstruction, it's not an option anymore. You then have to deconstruct, which then asks the question, so who can do that deconstruction? In the case of Portland, for example, we now have 17 certified deconstruction companies that are actually running the city, right, in terms of all of these deconstruction projects. There's competition, there's economy of scale in terms of that. And the price of a deconstruction and a demolition in Portland now is almost the same because of the fact that it simply built that system over time, right? And yes, that was incentivized in the very beginning, but it's not incentivized anymore. San Antonio is doing something super interesting. The city provides a material center. So everything that a deconstruction contractor cannot immediately bring to market, they can bring to that city-run material center, where it is then stored and cataloged and brought to market, centralized, which has many benefits. One being that in many cases, reuse has the problem that you have too little of the same item in stock, right? If you take a house down, you get 5 doors, but then the next project needs 7 identical doors, and then that design falls through because you can't fulfill the requirements of the market. So if you start pooling in stock, you're much more able to actually fulfill the requirements of the new design. So there are really well-working examples out there that show the feasibility of the system, but it's never been tried at a scale like a state, for example. And also, just to clarify that, we're not proposing a statewide deconstruction ordinance. I think that's the wrong jurisdiction to make that decision. These decisions are in the hands of our towns and municipalities and cities, and they need to be made locally because they are so dependent on availability of skill and storage and infrastructure and right? All the context that we just talked about is a very local context. But what we're trying to do is to kind of synchronize these efforts across the state to build a system. And that also makes it easier for each actor to situate themselves within the system.
Okay. Fun little question as we're winding down. Felix, are you still a partner at 2HS Architects over in Germany?
Yes, I also have a architecture and engineering office in Germany. 2HS is trying to be like an extension of our research. We're three partners. All three partners are in academia. And there's always this moment where when you build something driven by a university setting or a research setting, where you have to stop because you don't have insurance, you're not able to sign the plan to ask for a building permit. And so those are the moments where the office would take over and say, okay, we'll go the whole way. We want to build this in full scale and actually prove the feasibility of these ideas. So it's an unconventional office, but it's been very successful in actually materializing research ideas in full scale.
Oh, fantastic. Okay, my $1 million question. I ask every single episode, I ask every guest, and I ask them to answer the question from whatever perspective they'd like. So, Felix, what makes a great building?
Yeah, that's a really good question. I mean, considering what we just talked about, my answer has got to be that it's a material that is a building that is built out of reused materials and is designed for future reuse of these buildings, right? So it is somewhere after the first use cycle of materials and before the third, fourth, and fifth. But being an architect and loving design, I think I also need to add that a great building is one that that we enjoy being inside, that supports our activities, that is an important sort of keystone in the fabric of our urban environment. And I think even more important nowadays, it's a building that is using materials that do not harm us as humans. There's way too much VOCs and poisons and toxicants in today's built environment. And that goes back to the circularity aspect as well, because what we really don't want in circularity is to reuse toxicants or reuse poisonous chemicals for the next use cycle, right? So part of all of these strategies that we're talking about with urban mining or deconstruction is also to make sure that we get everything that is potentially harmful out of the way before we then continue the use of these materials for future building.
Right. Oh, fantastic. Okay. Before we go, do you have any announcements or exciting news that you'd like to share about yourself, Cornell, 2HS, the lab?
I think what excites me right now the most is actually the amount of movement that is happening in this area, despite maybe the feeling that this isn't the fact. There is a lot moving right now, especially on state and city levels. And something that hopefully will have a really great impact is a move to automatically assign timber grades to salvaged timber. And this is happening on the one hand side as a move to implement this in the International Construction Code. So that's a process that's being done right now, but it's also happening at state legislation to implement these as bills. And the reason why it's so exciting is because right now we have a huge amount of material that is extremely valuable, but that doesn't have a market because we're not allowed to use salvaged lumber structurally at the moment. We can do it in 2 states in the US, but not in the others. And so by shifting that code or policy, right, we're opening up a really valuable market for these materials, and with it, a huge potential for large scale use.
Right on. Fantastic. Felix, thank you so much for such an incredibly eye-opening, insightful conversation. I learned a lot today. Thank you for being on the show.
Thank you very much.
All right, take care.
Video.
We hope you enjoyed this episode of Better Buildings for Humans. For more information on the world's best light diffusing and highly insulating glass glazing, please visit advancedglazings.com.